Hi everyone, welcome back. So today's topic is looking at angles in polygons. So what are polygons? So polygons are shapes, okay, but these are special shapes that are closed. So for example, this shape over here is not closed, so that's not a polygon. It has to be a two-dimensional shape, okay, so they have to be flat. These examples here are 3D, so they're not polygons. And it has to be created using straight sides. All right, so that's why this ellipse, for example, is not a polygon, and this odd looking shape is also not a polygon. All right, so we're going to be looking at the sum of the angles inside polygons. So in this, on this page here, I'm going to go through and take a look at all these different shapes, and let's see if we can find some patterns. And we're going to use these patterns to see if we can come up with a formula for determining the angle inside any kind of polygon. So let's say we have a polygon that has 100 sides, right? How would we determine what the inside angles add up to, right? So for example, the triangle, we know that that shape, the angles inside that shape will add up to 180 degrees. A quadrilateral, the angles inside a quadrilateral, if they're all 90 degrees, are going to add up to 360. So it changes as the polygon changes. All right, so we want to come up with a general formula so that we can take any polygon with a different number of sides and be able to figure out what do the internal angles add up to. So that's kind of our goal for this page here. So triangle, I've got the diagrams already drawn for each of them. Number of sides, so I've just added the sides for each shape. And then the next column is number of diagonals drawn from one vertex. So if we have a triangle, essentially it's asking us to break this triangle into more triangles, but only by drawing a straight line from one vertex to another. Well, in this case, you can't do that because if there's one vertex here, another vertex down here, if you join those together, you're not going to create a new triangle. So for this one, it's going to be 0. The number of triangles that we have is 1 in this case. The sum of the angles in the polygon is going to be 180 degrees. Okay, so it's going to be the number of triangles times 180 degrees. If we look at a quadrilateral, like a square, for example, if we choose a vertex and then draw a straight line to another vertex, we can break this shape into 2 triangles. Okay, so it's one diagonal that we drew, which creates 2 triangles. All right, so the sum of the angles inside that shape is going to be 2 multiplied by 180 is 360 degrees, which we already know, right? Because a square has 90, 90, 90, and 90. 4 times 90 is 360 degrees. But we can arrive at the same answer by taking all the shapes we have and breaking them up into triangles, and then checking how many triangles we've created, and then multiplying that by 180 degrees. So let's do the same thing for a pentagon. So let's draw diagonal. So pick a vertex. So I'm picking this vertex here. I'm drawing a line across to another vertex. I can also draw a line from this vertex to that vertex down here. So pick a corner and then draw as many lines as you can to the other vertices. Okay, so when I do that here, I drew 2 lines and I created 3 triangles within the shape. Okay, so the sum of the angles within that shape is going to be 3 times 180, which is 540 degrees. Okay, and I'm going to continue that for the next shape. So we have a hexagon which has 6 sides. And I'm going to pick a vertex. I'm going to pick this one here and draw straight lines to as many other vertices that I can. So I'm drawing 3 lines in this case. And I've created 1, 2, 3, 4 triangles. So the sum of the angles within that hexagon should be 4 times 180, which is 720. So you could draw a hexagon to check if you wanted to, and you could measure the angles inside, and you will see they will add up to 720 degrees. So following the same pattern, if we have a shape with 100 sides, we should be drawing 97 diagonals, because if you look at the pattern, if we have 3 sides, we drew 0 lines, 4 sides, we drew 1 line, 5 sides, we drew 2 lines, 6 sides, we drew 3 lines. So you could see that the difference between them is 3 for each case. So if we drew a shape with 100 sides, we should be able to draw 97 lines. How many triangles should we be able to form? Well, you could see the number of triangles is always 1 higher than the number of lines that we drew. So we should be able to draw 98 triangles in that shape. And now we can figure out what the sum of the angles inside would be. It would be 98 times 180, which is 17,640. So let's write a general equation for any shape. So n-gon would be any shape. Okay, so we're going to represent that with n, and then n will be replaced by whatever the shape is. So if it's a shape with 50 sides, then in our equation n would be replaced with 50. So if our shape has n sides, how do we get to the number of lines that we drew? Well, it would be n minus 3. Right? Because all these values are being decreased by 3. And then for the number of triangles that's formed, it would be 1 higher. Okay, so instead of n minus 3, it would be n minus 2. And then it's this value here that gets multiplied by the 180 degrees to come up with the total number of degrees in that shape. Okay, so it would be n minus 2 times 180. So that's the general formula that we can use, and you can use this equation to find the sum of the angles in any polygon. You just replace the n with the number of sides that that polygon has on the outside. So there's the equation again, 180 times n minus 2, which is the same as I had over here. Whether you write the 180 in the front or at the end, it doesn't make a difference. So let's do some examples. Find the value of each variable and state the reasons. So let's find the missing value in here. So we know a quadrilateral has to add up to 360 degrees. So in order to find this x, it would be 360 minus the 3 sides that are given to us, which is 111. Question B. So in here, what I've done, there's different ways to solve these types of questions, but what I noticed right away is that if this angle here is 125 degrees, then this angle down here also has to be 125 degrees. So I'm going to call that angle Y. Okay, and so I'm going to say angle Y is equal to 125 degrees because of the opposite angle theorem. And now once I have this angle in here, I can easily find angle X, because these two angles together have to add up to 180 degrees, and that's because of the C pattern. You might remember that from an earlier lesson. This makes a C pattern, and the internal angles on the same side are always equal to 180 degrees. So that's what I've done here. So I said 180 minus Y will be equal to 55 degrees because of the C pattern. And the last example on this page, we're finding the last side. So this is a 1, 2, 3, 4, 6-sided figure, which means it's a hexagon. And so we want to find what the sum of the interior angles is going to be first before finding that last angle. So a hexagon, the sum of the angles in a hexagon, we're going to use this formula here and replace the n with 6. Okay, so that was going to give us 720 degrees. So together they have to add up to 720, and if I subtract the ones that are given, I will be left with the x, which is the last angle. Okay, so I did 720 minus all the given sides or angles, so x is equal to 130 degrees. Example 2, find the sides of each angle in a regular polygon with 36 sides. So regular polygon is a polygon where the sides are equal to each other. So in the first step, you want to find the sum of the interior angles of this polygon. So what do all the angles have to add up to if there's 36 sides? So we're going to use our equation here, replace n with 36, and we're left with 6,120 degrees. So that's the total amount of degrees in a figure that has 36 sides. And since there's 36 of them, they're all going to be equal to each other. So in the second step, I'm going to take this value and divide it by 36. And that will give me the value of each of those internal corners. How many sides does a regular polygon have if the sum of the interior angles is 3,060? Okay, so for this question here, I'm going to use the same equation. Okay, but now I'm given that the sum of the angles is 3,060. So that's what I'm replacing in my equation. And my goal here is to find that n. Okay, so what you could do here, you've got a couple choices. You could expand this, so multiply the 180 by the n and then by the -2, and then solve for n using that method. Or since this is being multiplied by 180, I could eliminate that 180 first by dividing both sides by 180. So that's what I'm going to do here. So 3,060 divided by 180 gives me 17. And then on the right-hand side here, these just cross each other out. So I'm left with n minus 2 on the right-hand side. Now I want to add 2 to both sides to eliminate the -2 from the right-hand side here. So we have n equals 19. Okay, and I just answered the question here. Therefore, a polygon with 19 sides is going to have a sum of 3,060 degrees. And the last question, how many sides does a polygon have if each of its interior angles measures 140 degrees? So what you need to also realize is that the sum of the interior angles is equal to the size of the angle multiplied by how many angles there are. Okay, so if I know that each angle is 140 degrees, if I multiply that by how many sides there are, that's going to give me the total number of degrees. Okay, in the entire, it's a sum of the interior angles. So I've replaced the sum of the interior angles with 140 times n. And for this question, what I chose to do, in the last question, I chose to divide by 180. In this question here, I'm doing it a little bit differently. I'm choosing to eliminate the bracket. So I'm multiplying the 180 by everything inside the bracket. I just wanted to show you the other method. That's why I'm doing it a little differently here. So 180 times n is 180n, and 180 times -2 is -360. So our goal is to collect the n's on one side and the constants on the other side. So I've moved the 180n over to the left, and its sign changed to negative, okay? Or you can look at it as subtracting 180n from both sides. Okay, so now you want to collect like terms on the left-hand side. So 140n minus 180 is -40n equals -360, and then divide both sides by what is in front of the n, which is -40 in this case. On the left-hand side, they're going to cancel. And we're left with n equals 9. Okay, so a figure whose interior angles are going to be 140 degrees each needs to have 9 sides. And that's it for the examples. So there's a bit of homework that I assigned. There's an attachment in the Google Classroom that you can take a look at. I believe there's 10 questions for you to do. And also, if you watch this video, that gives you an opportunity to try this puzzle here for a bonus question. So just pause the video so you can see the question here, see if you can solve it. If you find out the correct answer, either send me an email or just add that to your homework and I will give you some bonus marks on your homework. Thank you for watching the video and good luck with your homework.